Good morning students. Free energy or G. We already discussed that total entropy change, that is delta S total, decides the spontaneity. Okay, but most of the reactions are closed or open systems. In such cases, both enthalpy and entropy change occurs. So, neither decrease in enthalpy or increase in entropy, decrease in enthalpy nor increase in entropy determines the direction of spontaneity change. So, a new term was introduced and it is called as free energy, or we can say Gibbs free energy. It is denoted by G. Okay. Now, let us discuss what is free energy. Free energy is an important thermodynamic parameter applied to the system and it is denoted by letter G, and it is also called as Gibbs free energy, and it got its name after the scientist J. Willard Gibbs, who introduced this, and this free energy got its name Gibbs free energy. Okay, now what is Gibbs free energy? Gibbs energy of a system is defined as the maximum amount of energy available to the system that can be converted into useful work during a process. Okay, so it is defined as the maximum amount of energy. Maximum amount of energy available to the system. Okay, available to the system which can be converted into useful work during a process. Okay, that can be converted to useful work during a process. Okay, this is called as Gibbs free energy and it is denoted by letter G, and G will be equal to H minus Ts, where H is enthalpy, we know T is temperature and S is entropy. So G is equal to H minus Ts, and T is absolute temperature. And what are the important characteristics of G? G is a state function and it is also an extensive property. It is a state function and extensive property. Now, let us derive Gibbs Helmholtz equation. So, we know H is equal to U plus PV and G is equal to H minus Ts. Okay, now change in free energy delta G will be equal to delta H minus delta Ts. Okay, we can write like this, and we know delta H is equal to U plus PV, or delta G is equal to delta U plus delta PV minus delta Ts. So at constant temperature and pressure, at constant temperature and pressure, what happens? P will be constant and T will be constant. So delta G is equal to delta U plus P delta V, because there is no change in delta P. Okay, there is no change in P because at constant pressure, and this will be equal to T delta S. There will be no change in temperature because at constant temperature. Okay, so this will be the equation, or we can write delta G is equal to delta H minus T delta S. This equation is known as Gibbs Helmholtz equation. Okay, this is called as Gibbs Helmholtz equation. This is very helpful. This is very important and it is very useful in predicting spontaneity or feasibility of a process. Okay, spontaneity or feasibility of a process can be easily determined by using this, the change in Gibbs Helmholtz equation or change in free energy. Okay.